Hello, in this video we're going to take a look at surface area of right prisms. And when we calculate right prism surface area, we're looking at the faces and finding the area of each face or side of the three-dimensional shape. And we use formulas to calculate areas of regular shapes. And then when we take all those sides, we combine them or add them to find the total surface area. Sometimes I feel that it's important for you to use shapes that you have around your house just because you can manipulate a three-dimensional shape. So you can touch all the sides just to check that you have everything accounted for. I'd like to start off with this first example on page 531 just to show you a different way to solve compared to how the book shows. So they're asking you to find the surface area of the triangular prism. And you need to be particularly careful with triangular prisms because the rectangles can be the same size or they can be different sizes. We determined in an earlier lesson that we can figure out how many pieces of this three-dimensional shape there are by counting the sides and noticing that the faces dictate the shape. So we have 2 triangles here and 3 rectangles that comprise this figure. I like to draw the shapes so that I can label them. So I have 2 triangles and I have 3 rectangles. And then I can go ahead and label these so that I can calculate their area for easy solving. For the triangles, we have a base of 8 and we don't need the 5 meters on the sides. We need the height, which is shown to us at the right angle, just 3 meters. So this is an 8 base with a 3 meter height, and we have 2 of those triangles that are the same. For the rectangles, we look at the bottom down here. This is 8 meters on one side by 7 meters on the other side. So this is an 8 by 7 rectangle. That is different from the tops. The tops have a one side of 5, indicated that both sides here are the same, and the one side is 7. So here we have 2 rectangles on the top that are the same, 7 by 5. Now we can calculate all these areas and we can add them all together. So for our triangles, we have base times height divided by 2, and we have 2 of those that are the same, plus a length times width, and then we have the 2 that are matching. I'm just going to show it as 3 added together. There's so many ways to solve, you need to find what works best for you. So for the triangles, I have base times height divided by 2, and 2 of those, so 8 times 3 divided by 2, which is 12, times 2, which is 24. So this is 24 square meters, plus 8 times 7, plus 7 times 5, and again 7 times 5. So you could multiply 7 times 5 times 2 if you would like. I'm just going to show each one separately. 8 times 7 is 56 square meters. 7 times 5 is 35 square meters, and again, another 35 square meters for the other top. When we add all of those up, we get a total surface area for this entire figure at 150 square meters. I encourage you to write down or draw the shapes so that you may label them and that you may be able to see everything you're doing and account for all your sides. And you'll also be able to fix your mistakes more easily if you present everything to yourself in an organized way. The next example is a cube. So a cube is made up of squares, and as we know, squares have equal sides as shown in the diagram. And a cube is made up of 6 squares. The area formula for a square is the side squared. So because we have 6 of them, we can take the area of the cube as being 6 multiplied to the side squared. So cubes are very nice. We can take 6 multiplied, and the side length is 4 millimeters, squared. Now remember your bed mass, you need to do the squaring first. 4 times 4 is 16 square millimeters, and 6 times 16 is 96. So cubes are often your easiest shapes because they're comprised always of 6 equal sides, 6 squares. For the student example, you may find it very useful to draw a diagram. So Anne wants to paint the walls of her bedroom. If the room is 3.5 meters long, 3 meters wide, and 2.5 meters high, how much paint will she need to cover the walls? If paint costs $1.49 per square meter, how much will the paint cost? So I'm going to try to draw the bedroom here a little bit. I'm going to draw a box, which is basically what a bedroom is. And we know that she's not going to paint the floor and she's not going to paint the ceiling because they didn't tell us about those. They just said the walls. So we can label here, and when we label, we see that we have one length of 3 meters. We have one which is 3.5, and it doesn't matter which order you put these in, and that the height is 2.5. And when we draw this, we can discover that the front and back walls are the same dimensions and the side walls are the same dimensions. And we are dealing with rectangles here, and the area of a rectangle is length times width. So we have 2 sides that are 3 by 2.5, and we have 2 sides that are 3.5 by 2.5. So because we have 2 of those, we can multiply them by 2, or again, you could make a label of all your sides, and you could label them out, which would be very handy so that you can visualize in 2-dimension what they're talking about in 3-dimension in the problem. Once you have this calculated, you will determine that you've got a side lengths. The 2 together make 15 square meters, and the other 2 sides together make 17.5 square meters. So the total for the square footage is 32.5 square meters, and that's the total surface area of these 4 walls. So that's part 1. That's answering the first question. Second question is asking you to calculate the cost. So we have $1.49 per square meter multiplied to 32.5 square meters will give us our total cost. And when we put that in our calculator, we see that the paint here is going to cost $48.43. That seems pretty cheap to me, knowing what paint costs these days, so we may have to double or triple this paint cost to be accurate to today's prices. But that's the cost of painting Anne's bedroom if she's to paint the 4 walls. In the next video, we'll take a look at the second student example for a triangular prism that's a little bit more involved.